Okay, welcome to your very first video lesson, and this lesson is on slope. Slope is something everyone has seen many times in grade 9. It was a huge focus last year, but pretty much slope is a measurement of the steepness of a straight line or a line segment. The higher your slope, the steeper the line. The smaller the slope, the less steep it is, so it's closer to that horizontal line. Now, the slope is also known as a rate of change, how much one variable is changing with reference to another. And rate of change, we kind of hear it more when we get to word problems. When you just have a random line segment, we're just going to refer to it as the slope. Now, where do you see slope in the real world? We see it with wheelchair ramps. That's a really big example that you probably saw last year. You see it with mountains and hills, roads, anything that is on an incline. Okay, now the symbol that we use for slope is m, little m. And that's important because later on we're going to figure out what uppercase M is, and that will not be slope. Now, if we look at this little triangle on the right, when you have a line segment, the actual slope is calculated by creating a rate triangle. And when we create a rate triangle, we pretty much pick 2 points on our line and we create a triangle between them. And that way we can see how much is our line rising for a certain run. And that's what gives us our first formula, which is rise over run. We have to remember, though, that rise is that vertical change and run is the horizontal. So make sure you don't confuse them as run over rise, or else it's going to mess up your slope. So let's try that for this first example, where we're going to compare the slope of two ski hills. We have hill A, okay, which has a rise of 100 meters and a run of 800 meters. So now when I want to calculate my slope, I'm just going to put the rise of 100 over the run of 800. Now that's a really big number. It's kind of messy. I'm going to simplify my fraction. I can divide my numerator and denominator by 100 to get 1 over 8. Okay, and now we're going to do the same thing for hill B, but now our rise is 300 and our run is 800. So my new slope for hill B is going to be 300 over 800, which is 3 over 8. And now I can compare these two fractions and see which number is larger. The larger the number, the steeper the hill in this case. Now in this case, both of our fractions have the exact same denominator, so we can just compare our numerators. 3 is greater than 1, so 3/8 is larger than 1 over 8, so hill B is steeper. If our fractions had different denominators, we could just go to our calculator and turn our fraction into a decimal by doing the division and comparing it that way. So I'm going to write, therefore, hill B is steeper. And just in brackets, I'm going to write y, because 3 over 8 is greater than 1 over 8. Okay, now we're going to look at our 3 different formulas for slope. We already looked at rise over run, and again, that's only if you have a rate triangle. The other one is if you're given 2 coordinates, you don't have a visual, but you want to calculate the slope, and that's going to be y2 minus y1 over x2 minus x1. And these are just the coordinates of your 2 points. You're going to label one point as x1, y1, and the other point as x2, y2. It does not matter which point you label as 1 and which one you label as 2. It'll work regardless. And this takes us to our last formula, which is change in y over change in x. Now, whenever you're subtracting 2 coordinates, you're finding that change in their values. And this symbol right here, this triangle, means change in. And you'll see that in science as well. Okay, so let's try to use that slope formula, y2 minus y1 over x2 minus x1, to practice calculating the slope for the following pair of coordinates. So I'm going to do the first one. I'm going to label my points as x1 over here, y1, x2, y2. You do not have to label your points, but it might be a nice way to organize for your formula. So we know our formula is y2 minus y1. y2 is negative 4, y1 is 4. So I'm going to subtract negative 4 minus 4. And then x2 is 2 minus, x1 is negative 4. Be careful here with those double negatives. And now I'm going to simplify. Negative 4 minus 4 is negative 8. 2 minus negative 4 becomes 2 plus 4, which is 6. And now I'm just going to simplify my fraction. I can divide both by 2, and I end up with negative 4 over 3. And that would be the slope of my first set of points. Okay, and now let's go to B. Again, I like to label x1, y1, x2, y2. And now I can go to my formula. Negative 3 minus 2, 0 minus negative 1. And again, we have to be careful with that double negative. Make sure you're always putting the y's on the top, the x's on the bottom. And now when I simplify that, I end up with negative 5 for my numerator and positive 1 for my denominator. And if I simplify negative 5 over 1, anything divided by 1 is itself, so my final answer is negative 5. Okay, I want you guys to pause the video right here, and I want you to try to find the slope of C on your own right now. Okay, so for C, my y2 is negative 2, my y1 is 8, so I subtract those. x2 is 4, x1 is 0. When I simplify, I get negative 10 over 4. If I divide both numbers by 2, I get negative 5 over 2 as my slope. If you got that right, perfect. I want you to pause the video again and try D. If you didn't get that right, find your mistake, correct it, and try D, and really try to not make that mistake, whether it's you mixed up X and Y, you labeled incorrectly, try to find your mistake. Okay, for D, our slope, y2 is 3 minus y1 is negative 3. Be careful here, I hope you didn't make that mistake. x2 is 7 minus x1 is negative 1. I'm going to simplify. This becomes 3 plus 3, which is 6. The denominator becomes 7 plus 1, which is 8. And again, I divide my numerator and denominator by 2, and my final slope is 3 over 4. If you got that right, perfect. We're ready to move on. If not, please find that mistake, make a little note of it, star it, so that you can get more comfortable and you remember the slope formula. The last thing we're going to do with slope is review a few properties. So if we look at that first summary box, when your line is going from left to right in an upwards direction, our slope is positive. Okay? When your line is going in the downwards direction from left to right, our slope is negative. When we have a horizontal line, our slope is 0, and that is because our rise in this case is 0. Yes, we have a run, but 0 divided by any number that represents your run, if you were to create a right triangle, is 0. When you have a vertical line, though, our slope is not 0. Our slope is not a number, in fact. Our slope is undefined. And that's because now we have a rise. We have a rise that we can put in our fraction, but our run, we're not moving left, right at all. Our run is 0, and we cannot divide by 0. If you don't believe me or forget from grade 9, go to your calculator right now and do 5 divided by 0, 1 divided by 0, anything divided by 0, and you're going to get an error, and that's because we can never divide by 0. The other thing I want us to summarize is about parallel versus perpendicular lines. The slopes of parallel lines are equal. They are the same. If our lines are traveling in the exact same direction, that means if we were to create a right triangle, our rise and our run would be identical. For perpendicular lines, the slopes are negative reciprocals. And what that means is, negative means flip the sign. So if one slope is positive, the other is going to be negative. If one slope is negative, the other will be positive. And reciprocal means flip the fraction. So switch the numerator and the denominator. Okay, so let's try a few examples right now. So line segment J has a slope of 2/3. If the line segment K is parallel, then the slope is going to be the exact same. Our slope is going to be 2/3. If our slope is perpendicular, like line segment L, then we're going to take the negative reciprocal. So my original slope is positive, which means the negative reciprocal is going to be negative. And now I'm going to flip my fraction. So instead of 2/3, I'm going to have 3/2. So the perpendicular slope is going to be negative 3/2. Okay, if we look at example B, now our line segment M has a slope of 2. We can write that as 2/1 so that we see it in fraction form. If line segment N is parallel to M, then the slope is also going to be 2. If line segment O is perpendicular to M, okay, we have a positive slope, so the negative reciprocal, we're going to make it negative, and now we're going to flip our fraction from 2/1 to 1/2. And now our last example. Line segment P has a slope of 0. So if line segment Q is parallel, then the slope is also 0. And I'm going to make a note just to recap. When our slope is 0, we have that horizontal line. If line segment R is perpendicular to P, then its slope is going to be undefined. If we know our line segment is originally horizontal, the perpendicular is automatically going to be vertical, and any vertical line has an undefined slope. And again, I'm going to make a note that that is vertical. And that's it for your slope review.